Security teams build defensive walls, and attackers look for the cracks. For decades, this was a manual process on both sides, but that balance is collapsing. Standard security measures are failing to keep up with the sheer volume of automated threats. Advanced language models are now identifying zero-day vulnerabilities in heavily audited software. They are autonomously writing exploits for bugs that have remained hidden in operating systems for over 20 years. You can use these exact same capabilities to defend your systems. In this video, we are going to build an autonomous, agentic bug hunting pipeline. To set this up, you need 3 specific components: container infrastructure to run tests, a target codebase to analyze, and frontier language model API access. Threat actors are already scaling their operations with AI. Constructing this automated pipeline right now is the most effective way for defenders to outpace them. This diagram maps out the first architectural step: isolation. We place the project under test inside a closed-loop sandbox container with a strict firewall, completely cut off from external networks and production environments. This isolation is non-negotiable. The goal of this agent is to write and execute untrusted exploit code. If it succeeds, you do not want that code accessing the open internet or your actual systems. This hierarchical heat map represents file ranking. The model assigns a bug probability score to every file. A file parsing raw internet data receives a high-risk 5, while static constants receive a 1. This ensures we prioritize relevant targets. This prioritization turns the AI from a blind brute force scanner into a surgical investigative tool, focusing entirely on the code most likely to break. We deploy multiple parallel AI agents, attaching one to each high-priority file. Each runs a continuous workflow loop, hypothesizing flaws, inserting custom debug logic, and running experimental scenarios. If it fails, it rewrites its approach and tests again until triggering a vulnerability. To see exactly how effective this is, let's look at the FFmpeg media library, specifically the H.264 video codec. FFmpeg is one of the most thoroughly tested software projects in the world. Yet, the agentic pipeline successfully identified a memory safety flaw that had gone unnoticed for 16 years. The flaw involved an out-of-bounds array index, where a slice counter collided with a padding entry. The AI succeeded by understanding the contextual logic of that specific array, allowing it to manipulate the padding directly. Traditional fuzzy tools rely on throwing millions of random inputs at a program, hoping for a crash. Agentic testing applies deep contextual logic to unearth vulnerabilities buried inside complex structural code. Finding a crash is only the beginning. The agent must meet a strict output requirement. It has to generate a formal bug report containing a proof-of-concept exploit, detailing the exact steps to reliably trigger it. Running multiple agents in parallel will generate a massive amount of these reports. To prevent alert fatigue, we implement an AI triage filter. A final agent evaluates raw POCs to isolate critical threats. While many bugs are technically valid, they occur in obscure edge cases. This filter actively discards those minor problems. The autonomous pipeline takes that single, verified critical threat and routes it directly to a human security engineer. This system does not replace human engineers. It acts as a massive filtration mechanism, ensuring your team spends its time actively patching confirmed threats rather than chasing down false alarms. We now have a complete 24/7 autonomous security workflow. It prioritizes targets, proactively hunts for logic flaws, and filters the results down to actionable reports. You no longer have to rely on slow, reactive manual auditing processes that can take weeks to complete. AI capabilities will only continue to scale. By adopting this workflow now, defenders can shift the advantage back to their side of the board. Don't wait for future models. Use the current frontier models to build this scaffold today and secure your code before it ever ships.